All right, guys. As you know, I'm not here today because I have a doctor appointment, but I want to go over this lesson with you. Let me get it back where it belongs. We're going to start, this is lesson 9, session 1, and we're going to start with our learning targets for this week and what we're doing. We're going to be doing subtraction with negative integers. Our learning targets are to use models to subtract positive and negative integers. We're going to rewrite a subtraction problem with integers as an addition problem. We're going to find the distance between two integers on a number line. All right, so we've done a lot of this already. The only thing different is now we're going to take a subtraction problem and make it an addition problem. All right, we'll start with same or different. I want you to take a look at these and see what you come up with. I'll ask the teacher to pause the video to give you some time to think about it, and when you come back, we'll discuss the answers. Right? The answer, the things that are different. A is the only one that starts with a negative number, right? And D is the only one that has more than two terms. And if you look at D, 10 plus a negative 1 plus a negative 1 is the same as 10 plus a negative 2. So C and D are the same. And let's see what else. And then if you look at B, B is the only one that has actual subtraction as the operation. All right, so that's your same and difference. Let's go ahead and get into the lesson for today. All right. What we're going to do is ask this question. What happens when you subtract negative numbers? What's really happening when I subtract a negative number? I want you to think about that and pause the video, discuss at your table, and then when Mr. Phillarp's ready, he'll start the video. All right. So what you should have came up with is that when you subtract a negative, you're really adding positives. All right. So let's look at our problem that we have. We have Sierra has $5. She plans to spend $2 on a notebook. She can use the expression 5 minus 2 to find out how much money she'll have left after buying the notebook. If we do the counter chips, and these are positive chips, if she spends money, right, we can cross out those chips, right? We can cross out those chips by using a negative chip. Basically, I could do a counter like this, a negative counter and a negative counter. And that would create a zero pair. We're just going to just cross these out. And that leaves $3, right? How much money does she have left after buying a notebook? She'll have $3. So the answer to that question is $3. All right? How does the model show it? Well, it shows it by having 3 positive chips left. Each chip represents $1. All right. Another way to represent spending $2 is with the integer negative 2, right? So if we do that, we can just use the expression 5 plus a negative 2, find out how much money we'll have left, right? Integer, this chips will show modeling 5 plus a negative 2. We have 5 positives, we add a negative 2. And once we do that, we can cross these out. They go away, they form a zero pair. Everybody remember that word, zero pair. That was a vocabulary word last week, right? So we should still know what that means. So we cross those out, and again, we have 3 left. Why are these 2 positive chips and 2 negative chips crossed out? Because they form a zero pair. All right, how are those 2 models similar? Well, one way they're similar is that they both start with positive 5 positive chips. The first one, we had the 5 positive chips and we just crossed out what we were going to spend. The second one, we added 0 pairs. All right, and you can think You can share with your partner. I think two models show the same value because, and then tell them why you think they show the same value. They both started with 5 positive chips, and they both end up crossing out 2 of those positive chips. All right, we can also subtract negative numbers, right? We can use integer chips to find out -5 minus a -2. Subtracting -2 means taking away -2. I'm not taking away 2, I'm taking away -2. So we're going to cross out the integer chips to show taking away -2. Well, if I take away -2, that means they're going away. I'm going to cross that one out, I'm going to cross that one out. So I'm left with -3. So my answer is -5 minus a -2 is -3. I can tell that because that's how many chips I have left. All right? Any questions on that? You can send me an email or you can ask me tomorrow. All right. We can also do it with counters, positive and negative counter chips. If we do that, we put the 5 negative counters out, and then we put out 2 positive chips and we line them up underneath, because this allows us to form our 0 pairs. All right, and since there's 0 pairs, we can cross those out. And what that leaves us is three negatives left. So what is -5 plus 2? -5 plus 2 is still -3. So we compare the models in problems 3 and 4. How do they show that -5 minus a -2 is the same as -5 plus 2? They show that by both of them having 3 negatives remaining, right? So that's how they show, those 2 different models show the same answer. All right. Where do you see 0 pairs in the models in problems 3 and 4? In problems 3 and 4, let's take a look at those. Problems 3 and 4 are when we did -5 and -2. The 0 pairs are when we add the two positives at the end, right? We add the 2 positives underneath, and it forms a 0 pair. And then when you share your thinking, it says, I think subtracting the positive numbers like adding the opposite of the number, and that's because if we subtract the positive, like adding the opposite, if I take the opposite of a negative number, that becomes a positive number. All right, this reflect, when you subtract a negative number, you get the same result when you add a positive of that number. Why is that? Because subtracting a negative, all right, subtracting a negative. I gotta get this to write just a little better. Right? Means we are taking negatives away. Another way to say taking negatives away is adding positives, right? In parentheses, we'll say adding positives, all right? Any question? Why is that? Well, because if we're subtracting a negative, that means that negative is going away. And that negative goes away, it leaves a more positive answer. All right, so let's think of a real world connection. All right, so you guys have heard me talk about this before. This is the USS Arizona Memorial in Pearl Harbor. Think of sea level as being 0 on a vertical line, with positive elevations above sea level and negative depths below sea level. When might positive and negative numbers help describe the situation be useful? Well, anything that has to do with elevation, describe positive, negative would be useful. If you're flying an airplane, if you're in a submarine, if you're scuba diving, any kind of thing like that, positive, negative numbers can help you more accurately describe the situation. All right. So in my own words, opposite numbers, what are they? This is your homework. So this is going to be your homework start for tomorrow. I want you to tell me, here's where we're having issues. Not being able to tell it, but the examples and non-examples. A non-example means what is it not? So I want you to give me a non-example of an opposite, right? For instance, I'll just give you a hint, right? If -1 is the opposite of 1, right? 1 and 2 are not opposites, right? So -1 and 1 are opposites. -1 and -10 are not. -1 and 10 are not, right? So opposite numbers are those that are the same distance from 0 on a number line. All right, and this is your homework for tonight. So I'm going to cut the video, and then I'm going to have the sub play this for you tomorrow. After that, you'll go on iReady, and you will do as much iReady as you can, and it's iReady math only, not iReady reading. All right, thank you, and I will see you guys on Tuesday.